Welcome to Math with Professor V. In this video, we're going to review some of the rules for simplifying radicals, and then we're going to see how we can apply those rules to help us evaluate limits in our calculus class. And we're starting pretty much at the beginning. So when you have expressions that contain several radical terms, you have to keep in mind that we can only add and subtract like radicals. Well, what do we mean by this? Think back to when you were just first learning how to combine like terms. If you had something like 3x plus 5x, we could simplify that to 8x. And similarly, if you have 3 rad 7 plus 5 rad 7, these are considered like radicals, and you can simplify by adding the coefficients on each of those two terms together and end up with 8 rad 7. However, something like 2 rad 3 plus 3 rad 2, this cannot be simplified. And it's somewhat akin to having the expression 2x plus 3y. Those are not like terms, those can't be simplified. So 2 rad 3 and 3 rad 2 are not like radicals. How can we identify what are like radicals? Well, they need to have the same index and the same radicand. And I'll explain what those terms are just in case you don't use them on the regular like I do. So it's not a big deal. Index and radicand, I'll show you right now. If you have the nth root of a, n, that's the index. And then the stuff underneath the radical sign, so a, that's the radicand. So both of those need to be the same in order for you to have like radicals, and then you can go ahead, add them, subtract them, just like with like terms. Let's practice a little bit, okay? So first example, add or subtract -4 rad 3 plus 9 rad 3. So these are like radicals. Both of them have the square root of 3, and then I'm just going to combine the coefficients. -4 plus 9, this gives me 5 rad 3. Don't touch the radical part, that doesn't change. Okay, example B, 16 rad 3xy plus 5 rad 7x minus 7 rad 3xy plus 9 rad 7x. So we have two sets of like radicals, 16 rad 3xy and -7 rad 3xy. That'll give me 9 rad 3xy. And then here's 5 rad 7x, 9 rad 7x. Adding those together, 5 plus 9, that's 14 rad 7x. And I can't combine any further because now these two terms that I have here are not like radicals, so we're done. Okay, good. Example C, 7 rad 2 plus rad 8. Now, initially you might say, well, these are not like radicals. You're correct. But rad 8 is not completely simplified. Remember, 8 is 4 times 2, so I can rewrite it as 2 root 2. So root 8 is square root of 4 times 2, which becomes 2 root 2. If you need help simplifying radicals in that way, I have a video already recorded. I'll link it in the description for you, okay? Good. So then now I can see, oh yes, indeed, I do have like radicals. So this is just going to give me 9 rad 2. Good? Okay, example D, cube root of 27 plus 5 times the cube root of 8. Well, cube root of 27, that's just 3, isn't it? Plus 5 times cube root of 8 is 2. Very good. So this actually just ends up being 3 plus 10, which is 13. Oh, that was lovely. Okay, so now hopefully you feel more comfortable, more refreshed on how we add and subtract radical expressions, only if they're like radicals. Now, what about multiplication? So if you have something like 8 rad 3 plus 4 rad 2, you can always think back to how you treated terms with variables in them. For example, if you had 8x times 4y, wouldn't that become 32xy? Okay, so same thing basically here. 8 times 4, that's 32. Then you multiply the radicands by each other, and you put them underneath the same radical. So now you're going to have square root of 3 times 2, which is 6. And then you're done. That wasn't so bad, right? Okay, let's try a few more though, obviously, so we can build on this idea. And we also can find products and quotients involving radical expressions of more than one term. So let's practice simplifying completely. Here we have rad 3 times rad 7 plus rad 6. So we're going to go ahead and use our distributive property. All of our old rules still apply. So square root of 3 times square root of 7 is square root of 21 plus square root of 3 times square root of 6 is square root of 18. And then just keep in mind this said to simplify completely. Square root of 18 simplifies further, right? 18 is 9 times 2. Square root of 21 doesn't simplify, so I'm going to leave that guy alone. And then 18 is going to simplify to 3 rad 2. Again, like I said, if you have a hard time simplifying radicals like rad 18, then just watch the video that I link in the description. I'll put it up in the corner here too right now. Okay, example B, 3 rad 7 times 2 rad 7 plus 4 rad 5. Now I want you to notice something. When you distribute these first two terms here, 3 times 2, that's 6. Rad 7 times rad 7 is rad 49. Oh, but that's just 7, isn't it? Yes. So if you want to make a note as a little shortcut, rad 7 times rad 7, we just saw it's rad 49, but then that ends up just being 7. So you can kind of just skip this step if you want. When you have the square root of some number times the square root of itself again, then you just get back the radicand. It should make sense too because square root of 7 times square root of 7 is square root of 7 squared. So then boom, of course you just get back 7. Okay, plus, and then the next term's going to be 3 times 4, so that's going to be 12. And then I multiply the radicands, so I'll have radical 35. Good? Okay, so this first term now, this is 6 times 7, that's 42, plus 12 rad 35. And no, don't combine them any further. Stop here, box it, not arrow it, box it, I said. Okay, there we go. They don't combine any further. Think about it like if you had 42 plus 12x, right? You can't combine those. The 42 and the 12 don't combine. So remember when you have that radical attached to a constant, think of it like almost a variable quantity. Unless everything's matching up, don't mess with it anymore. All right, now let's try something a little fancier. We're going to FOIL. Oh yeah, so rad 2 plus 5 rad 3 times rad 3 minus 2 rad 2. So first product, rad 2 times rad 3, that's rad 6, minus rad 2 times 2 rad 2 is going to be 4. Very good, because you're going to have rad 2 times a 2 times another rad 2. These are just going to give you 2, and then you have that other 2, so minus 4. Plus inner product, 5 rad 3 times rad 3 is going to be 5 times 3, minus last product, 5 rad 3 times 2 rad 2 is 10 rad 6. So what do we have going on? Rad 6 minus 4 plus 15 minus 10 rad 6. Let's combine like terms and like radicals. So negative 4 plus 15, that's 11. And then remember, there's a 1 here that we don't write. So we have 1 rad 6 minus 10 rad 6, so that's minus 9 rad 6. Fabulous. Very good. Okay, how was that one? Good? 5 minus rad 2 squared. If you need to, write it out twice because you still should FOIL. Or if you remember the rule for squaring a binomial, a minus b quantity squared, you end up with a squared minus 2ab plus b squared. So this is what I always do. It saves time. So just remember that a is 5 and b is rad 2. So I'm not going to write it twice in FOIL. I'm going to use this rule here. You should practice using it too. It'll help you in the long run. So a squared, that would be 5 squared, minus 2ab, so 2 times 5 times rad 2, plus rad 2 squared. And then this ends up being 25 minus 10 rad 2 plus 2. Can we simplify more? Yes, look, 25 plus 2. Love it. So 27 minus 10 rad 2. Good job. Okay, why don't you try using the same rule now for 4 rad 5 plus 5 squared. The rule changes just ever so barely. When you have a plus b quantity squared, then it's a squared plus 2ab plus b squared, okay? So 4 rad 5 is a, and 5 is b. So what's this going to be? It's going to be 4 rad 5 squared plus 2 times 4 rad 5 times 5 plus 5 squared. And then just be careful, when you have 4 rad 5 squared, you have to square the 4 and rad 5. So this is going to be 16 times 5 plus 2 times 4 times 5, that's going to be 40, and then keep the rad 5 there, plus, this is 25. And then 16 times 5, that's 80. 80 plus 25, that's going to be 105, plus 40 rad 5. That one's done. Very good. Okay. Now let's look at the next example, and this is something to pay attention to because all of the limit problems that we're going to do from calculus utilize this idea, okay? So 3 minus rad 5 times 3 plus rad 5. I want you to notice these are conjugate pairs. And when you have conjugate pairs, so a minus b times a plus b, do you remember what the product gives you? It just gives you a difference of squares, right? A squared minus b squared. You don't have to sit there and FOIL it. If you did, you'd have a squared plus ab minus ba minus b squared. And then the middle terms cancel out, which is why you just get this difference of squares, okay? So notice that's exactly what's going on here. We can just take a squared and then subtract b squared. So a squared minus b squared. And this is going to be 9 minus 5, which is 4. Wow. Okay. If if you're nervous, you can sit there and FOIL it all out and check, right? That's 9 plus 3 rad 5 minus 3 rad 5 minus 5. And then see, these guys cancel. But why go through all that when you can just cut to the chase? Boom. It's 9 minus 5, which is 4. Okay? So let's see if you guys got it. One more like this with conjugate pairs. 12 plus rad 12 plus rad 11 times rad 12 minus rad 11. Can you do it in your head and not write a single thing down except the final answer? It's 1, right? Because you have rad 12 times rad 12 minus rad 11 times rad 11. So this is just 1. Beautiful. So when you have radical expressions and you multiply by its conjugate, right? Then you end up with something that no longer involves radicals and it helps simplify. And this is something that we're going to need to do with the limit problems that are coming up, okay? Now, you should be familiar with the idea of rationalizing denominators. And in previous videos, I've gone over that. So if you need a little review, then I'll link that also in the description. All things and everything dealing with radicals, I got you. But what if you have a more complicated denominator that involves addition or subtraction with multiple terms? And we're going to see this. So what you need to do is multiply by the conjugate. If you have 1 over 3 plus rad 7 and you're asked to rationalize, what you need to do is come through and multiply by 3 minus rad 7. And then what that lets you do is, okay, the numerator's just going to be 3 minus rad 7. But now in the denominator, remember when I multiply these conjugate pairs, I get a difference of squares. So I'm going to have 9 minus 7. And then I'm left with 3 minus rad 7 over 2. Okay? And in algebra, it's always such a big deal to always have a rationalized denominator. You'll notice we kind of take a step away from that in calculus. Sometimes we'll need to rationalize the numerator instead. But just keep in mind, when you have multiple terms with addition or subtraction, the way to rationalize is by multiplying by the conjugate. Okay, so let's practice that first. So simplify completely. In this case, they just mean rationalize the denominator. Okay? So we have 3 over 2 minus rad 5. So what would be the conjugate of the denominator? Very good, 2 plus rad 5. So I have to multiply by that in the numerator and the denominator. Now, wherever you're actually multiplying by the conjugate and you have the difference of squares, multiply that all the way out. The other side, hold off on multiplying it out because sometimes it'll help you cancel in the next step. You'll see what I mean in just a minute. So I could distribute the 3, but I'm just not going to yet. Let's see. In the denominator, 2 minus rad 5 times 2 plus rad 5, that's going to give me 4 minus 5, yes? 4 minus 5. And then that's just negative 1. So 3 times 2 plus rad 5. When you have over negative 1, we don't leave it in the denominator like that. That's not proper. So what we're going to do is put it out front. So I'll put negative 3 times 2 plus rad 5. And then from here, nothing canceled, so I can go ahead and distribute. So this will be negative 6 minus 3 rad 5. Okay, how was that one? Good? All right, we'll do a couple more, don't worry. And then it's calculus time. That's where this is going. 5 plus rad 3 over 4 minus rad 3. So say we're going to rationalize the denominator. I want to multiply by the conjugate of the denominator, which would be 4 plus rad 3. Okay, 4 plus rad 3. All right. In the denominator now we're going to have 4 times 4, so that's 16, minus 3. That's going to be 13. And then I might as well just FOIL out the whole numerator. So 5 times 4, that's going to be 20, plus, this is 5 rad 3, plus inside 4 rad 3, plus rad 3 times rad 3, what's that? Good, just 3. Okay, can we combine any like radicals up top? Yes, 5 rad 3 and 4 rad 3. And then 20 and 3, those are like terms. So that's 23 plus 9 rad 3 over 13. Oh, that's as cleaned up as it gets. Okay. Box it and move on with your life. Last one, 4 over 3 plus rad 5. So conjugate's going to be 3 minus rad 5. Very good. So my new denominator, let's see. We're going to have 3 times 3, that's 9, minus rad 5 times rad 5 is 5. Now I'm going to hold off on multiplying out the numerator. 4 times 3 minus rad 5, and you'll see why. 9 minus 5 in the denominator, what's that? 4. And then I have 4 here. 3 minus rad 5. See, aren't you happy we didn't distribute that 4? Now it cancels so easy, and we're done. And this last problem segues nicely into the limit problems that we're going to look at, because you're going to do just that. So you're going to multiply by the conjugate. Wherever you're multiplying by the conjugate and you have the difference of squares, you multiply that all the way out. On the other side of the fraction though, don't multiply it out because the next step is going to involve you canceling. Okay, and we're going to practice this a bunch of times so you'll see what I mean, but this is precisely the technique that we're going to use moving on. Okay, so here we go. Now let's look at some of the problems that you've probably encountered in your calculus class. So find the following limits, and the first one we have is the limit as x approaches 9, square root of x minus 3 over x minus 9. Now you should always try direct substitution first. Remember, you should always just try to go ahead and plug in 9 for x. And if you get a number, you're good. But we don't get a number. We get 0 over 0, which is an indeterminate form. So then we go, okay, we need to play around with this guy. So since I see a radical and there's subtraction going on in the numerator, I think to myself, let me multiply by the conjugate. In this case, we're rationalizing the numerator, but it doesn't matter. It's going to help us. So I'm going to multiply by square root of x plus 3, top and bottom, okay? Now for limit problems, remember, until you actually substitute in 9 for x, you still have to keep writing lim in the front every step of the way, all right? So you will actually multiply out the numerator because that's where you have your conjugate pairs, but don't multiply out the denominator. I want you to just leave it, x minus 9 rad x plus 3, okay? Don't multiply that out. Upstairs, what do we have? So remember, we're going to end up with the difference of squares. Square root of x times square root of x, that's just x, minus 3 times 3, 9. Do you see? Aren't you so glad you didn't distribute the denominator? Because here's x minus 9, x minus 9. Fabulous. What's left when the numerator cancels out completely like that? You have a 1 upstairs, don't you? Okay. Over rad x plus 3. I'm still writing lim, and then now in the next step, it looks like I can go ahead and actually substitute in 9 for x, and I'll have my limit. So I don't have to write lim anymore. In fact, you shouldn't. So this is 1 over square root of 9 plus 3. So that's 1 over 3 plus 3, 1/6. Okay, good. I have more, don't worry. We're going to become professionals very shortly. I already am, you can join me. So limit as x approaches 1 of x minus 1 over the square root of x plus 3 minus 2. So again, always just check if I plug in 1 for x, 0, 2 minus 2, 0. So 0 over 0, indeterminate. And then I see radicals. Ooh, I go, maybe I'll multiply by the conjugate of this denominator and lovely cancellation will happen like in that last problem. The giveaway is the radical. That's kind of like what gets me thinking, ooh, it's conjugate time. So in this case, I need to multiply by conjugate of the denominator wherever there's radicals. So this will be rad x plus 3. Don't touch what's under the rad. You just change this sign when you're figuring out the conjugate. Plus 2. Yes? Okay, good. Rad x plus 3 plus 2. Now, you will multiply this out, these two conjugate pairs. Don't multiply out the numerator. So to stop yourself, why don't we rewrite it first so you're not tempted, okay? Just x minus 1, rad x plus 3 plus 2. Don't multiply it out, please. Okay. Now we have here rad x plus 3 times rad x plus 3. That's just going to be x plus 3 minus 2 times 2, which is 4. How are we doing? This got insanely crooked. I'm so sorry. I'm left-handed, so I kind of write it aslant. I got to get it together. Okay. Notice, yes, this is still limit. X approaches 1. The denominator simplifies to x minus 1. Aren't we so glad we did not multiply out the numerator? Because now, yes, x minus 1 cancels. Okay. Then we have the limit as x approaches 1. Radical x plus 3 plus 2. No more denominator, it's gone bye-bye. And then if I just plug in 1 for x, then I have square root of 4 plus 2. So that's 2 plus 2, which is 4. Good? Are you having fun? I hope so. Otherwise, you're going to have a miserable semester. Okay, here we go. Another one. Limit as t approaches 0, square root of 1 plus t minus square root of 1 minus t over t. Don't have a panic attack because there's 2 radical expressions in the numerator. It's all good. We're going to do exactly what we've been doing. So again, if you try to plug in 0 for t, nope, you get an indeterminate form, 0 over 0. So let's multiply by the conjugate of the numerator. And the conjugate's going to be square root of 1 plus t plus square root of 1 minus t. So only change the sign right here between the radicals. Don't touch what's underneath the radical sign. Don't touch the radicands, please. They should not be messed with. And then same thing in the denominator. That way we're just multiplying by 1, right? We're not doing anything illegal. So then this is the limit. T approaches 0. Now, don't distribute this. Just leave it. T times rad 1 plus t plus rad 1 minus t. And then yes, let's go ahead. The numerator is going to give me a difference of squares, so I don't have to sit there and FOIL. Rad 1 plus t times rad 1 plus t is just 1 plus t minus, always a difference of squares, rad 1 minus t times rad 1 minus t is 1 minus t. Are we okay? All right, so this is 1 plus t minus 1 plus t in the numerator. So we've got the limit, t approaches 0. In the numerator, I'm just left with 2t now. And then I have t times square root 1 plus t plus square root 1 minus t. And then these t's cancel, ooh la la. And then we have limit, t approaches 0, 2 over square root 1 plus t plus square root 1 minus t. Can I finally substitute in 0 for t? You sure can. So this is going to be 2 over square root of 1 plus 0 plus square root of 1 minus 0. So 2 divided by 2, just 1. Oh, how fun. How fun. All right, you guys, are you getting the hang of it? I've got 2 more. Why don't you pause the video, see if you can do this next one on your own. I have so much faith in you. I think you can. All right, did you pause it? I hope you did, because that's really a good way to tell if you truly understand how to do them on your own, you know? I'm so sorry I can't be there with you when you take your test whispering in your ear. So we're going to multiply by the conjugate of the numerator, square root of x squared plus 12 plus 4. Okay. Should I distribute down here? No, right? I hope you were yelling at me. No, Professor V, we don't distribute on the other side. So to stop yourself, let's write it out so we know not to do a thing down here. Don't do anything. Then upstairs, we're going to have a difference of squares. Square root of x squared plus 12 times square root of x squared plus 12 is just x squared plus 12. Minus, always minus. It's always a difference of squares because you have a minus times a plus. That's how it's always going to work. 4 times 4, that's 16. Okay. So then this is the limit. X approaches 2. X squared minus 4 over x minus 2 square root of x squared plus 12 plus 4. And you might be saying, it's not canceling right away the way all the other problems did. I know, don't worry, it will in just a hot second. We got to factor further. X squared minus 4, that's a difference of squares. Doesn't that factor? We have limit x approaches 2. That'll factor into x minus 2 times x plus 2. Then we have x minus 2 here still. Just rewrite that whole denominator. Just keep it going. Now we can cancel. Hooray! X minus 2 is out of there. So we've got the limit as x approaches 2, x plus 2 over square root of x squared plus 12 plus 4. Can I substitute in 2 for x now? You bet. So then we have 4 up here over square root of 4 plus 12 plus 4. So this is going to be square root of 16, that's 4. 8. 4 divided by 8, this is 1/2. Okay, did you get it right? Grand finale. This one's lovely. Are you ready? Last one. The limit as t approaches 0, 1 over t times the square root of 1 plus t minus 1 over t. So yeah, if you try to substitute in 0 right now, we have problems. We don't have 0 over 0, but 1 over 0 approaches infinity, depending on which side we're coming to 0 from, and they didn't specify. And so if we assume, say, from the right side, then this is positive infinity minus positive infinity. That's another indeterminate form. So what are we going to do? Not sit and cry. Oh no, we are calculus students. There is a solution to all of these. And just tell yourself that too. When you start having like a little meltdown, just go, calculus has been around for hundreds of years, okay? This stuff hasn't changed in any significant way recently. So probably it's something you can figure out. It's not beyond your grasp, okay? First things first, I go, this looks different than all the ones we were doing before. All the ones we were doing before just had one fraction, one expression to deal with. This one has 2. We've got subtraction. This is already making me nervous. So let me make this look like the other ones we were doing. I just want one expression. So why don't I get a common denominator? Yep, that's the thing to do. So look here. This is t rad 1 plus t. This is t. It's missing rad 1 plus t. So I'm going to go in. Let's multiply top and bottom by rad 1 plus t. That way we have a common denominator. Maybe that will make me feel better. That's literally how I used to talk to myself through problems when I was a student, okay? 1 minus, now we have square root of 1 plus t over t square root of 1 plus t. Good? 1 minus square root of 1 plus t, and then the new denominator is t square root of 1 plus t. Okay, good. Now it looks a little bit more like the other ones we were doing, right? Let's try multiplying by the conjugate of the numerator, because the numerator has subtraction. This doesn't have addition or subtraction, so it doesn't have a conjugate, okay? So the conjugate would be 1 plus square root 1 plus t in the top and the bottom. Where should I not distribute? Down here. Do not multiply out. You only multiply out the conjugate pairs. Okay. Limit t approaches 0. So to stop ourselves, let's just rewrite the denominator straight away and say, nope, I'm not multiplying this out. No way, no how. Now in the numerator, we'll have 1 times 1 minus square root of 1 plus t times square root of 1 plus t is just 1 plus t, but don't forget to put parentheses because that minus sign needs to distribute. That could be a dangerous moment. Okay, when it distributes, the 1's cancel, but what are we left with in the numerator? Very good, a negative t, yes, over t square root 1 plus t, 1 plus square root 1 plus t. Anything you notice you can cancel, The t is gone now. Goodbye. Fab. So then all I'm left with now in the numerator is a -1. So this is limit t approaches 0, -1 over square root 1 plus t, 1 plus square root 1 plus t. Can I substitute in 0 for t? Why, yes, I can. So this is -1 over square root of 1 plus 0 times 1 plus square root of 1 plus 0. So what is this? 1 times 2. So our final answer is -1/2. Wow, wow, wow. Beautiful, you guys. So that concludes the lesson. I hope it helped you really refresh and refine your skills working with radicals so that you can knock these calculus problems out of the park and not be intimidated when you see them, okay? And the key is multiplying by the conjugate. Don't forget to give the video a thumbs up, subscribe if you haven't already, and I have so many other video lectures set out on my playlist to help you get through your calculus courses, so be sure to check them out. Also follow me on Instagram, TikTok, Math with Professor V. Thank you guys so much for your support. I'll be back sooner than later. Bye.